In the last video, we have seen how we can use the simple linear regression algorithm. Okay, now we will talk about the multiple linear regression algorithm. Now, what's the difference between the simple linear regression and the multiple linear regression? Simple linear, when we have only one input variable or the independent variable. But in case of multiple linear regression, we have multiple input variables, or we can say multiple independent variable, based on which we will try to predict the dependent variable or the outcome. Okay, let's start with the problem statement which we want to resolve today. We want to predict the value for the output variable. Now, before starting with that, let's just first import all the essential libraries which we need. Pandas and NumPy we require for the data frame and the numeric value treatments. For visualizing the results, we have Matplotlib and Seaborn. As we are building the models, so for that we need some sklearn libraries to split the data in terms of training and the testing. Linear regression we are applying, so I'm just importing that also. And for accuracy, R2Score library we are using. Now, one new library we are introducing here, the label encoder. In the next subsections, we will see what and where we will be using this label encoder. Okay. Now, first we just quickly import the data. So here I am importing the data, that is the student performance data set I have. Through read CSV, I am just reading the data and storing into data frame DF. Top 5 values through the head function, I am just printing it out over here. Now you can see in the database our studied previous score, extracurriculum activities, sleep hours, sample question paper practices. These are the input variables which I have in my data set. So that's why we call it as a multiple linear regression, because we have more than one input variables in this. And the output is performance index. So we want to predict the value of the performance index here. Now just first analyze the data. I'm just finding out the stats of the data set. So this will give me an idea of data distribution, the stats property for my data set. Now I'm just visualizing the distribution of the data, how skewed the data it is. So these are all those features which I am using, or the independent variables which I am using to predict the performance index. This is the distribution for the hours studied, previous scores we can see, sleep hours distribution, the question paper practice, plus the performance index. So this is will be giving me the distribution of an individual variable over here. Now we will start the step for building the model. Now the one thing is, in our data set we have seen one feature, that is holding the non-numeric value, that is the extracurriculum activities. Now for applying the linear regression algorithm, we want that each and every parameter or the input value should be in a numeric form. So what we will do is we will encode that extracurriculum activities. Okay, so for that we are using the label encoders, or we can say we are just mapping the values. Okay, now here what I am doing is I am just labeling or mapping the values like DF. Let's first understand this. DF extracurriculum activities dot map. So what it will do, it will convert the value yes wherever written in the data frame to 1, and wherever it will find no, it will be replaced by 0. So now when I will try to see this extracurriculum activities, so this will be giving values 1 and 0 instead of yes and no. So in this form, we will be able to get all the input variables in numeric format only. Okay. Now let's just quickly run this module. I'm just first importing all those libraries. Okay, once this library is imported, then I'll import the database. Okay, so I'm using the Google Drive here, the Google Colab notebook I'm using here. I'm just importing my database. Now you can see my database is here. Now I'm just analyzing it using the describe. We can see the distribution of each and every input variable. And here I'm just running this block to make it more understandable. Let me just print the data frame. Now you can see the extracurricular activities. Previously it is coming yes and no. Now it has been converted into 1 and 0. Now my data set is ready. I can use it. Now second thing is X, the features I'm using for building the model, and I'm dropping performance index. Okay, so drop performance index, that means performance index is not the part of my features or the input variable. So let's just see what we left with is in X is, so we have in X, these are the variables, the inputs. We don't have the performance index here because that is our target or the outcome. Okay, so in Y we can see there is only the performance index. Okay, so now I have defined my features, the inputs and the outputs. Now split the data. I'm splitting the data using the train test split. X and Y, these are the features and labels. My test size is 20%. Random state 42 I'm specifying here so that it will start with the same state whenever the model training will be started. Now I'm having 4 different data set that holds the train and test for X and Y both. Now start building the model using the linear regression method. Okay, so I'm just first defining the linear regression algorithm and I'm trying to fit it by providing the training data set, that is the X train and Y train. Now my model training is completed at this phase. Now I just want to predict the results. So what will be my X train and the X test data? So now let me just execute this part. Okay, it's done. I'm just fitting my model and I'm trying to predict the values. Now through this, I am getting the test prediction in Y predict test and the train predictions in Y predict train. If I want to find it out, the accuracy of both the cases in the training and the testing phase, so I'm just using R2 score to find it out the accuracy percentage. So let's see, I am getting 98.87 in the train accuracy and 98.9 is the test accuracy. And I'm plotting is also okay, so I'm just plotting it out here, the difference between the actual and the predicted values. Now you can see this is my actual, this is my slope, and all those points are coming very close to the slope line, the straight line. That means my prediction is pretty much close to the actual one. Okay, so this will be a good performance of the algorithm. We are getting the accuracy. So this is ultimately the aim of the multiple linear regression, is to first to find out the relationship between the input variables and the output variables, plus it is specifically used when we have multiple features in the algorithm, and based on those multiple input features we want to predict the outcome or the dependent variable. Okay, so this is one of the example we have just now seen, that is based on the supervised learning, and that too be specific to the regression problems. Okay, I hope this is clear to everyone. Please, thank you so much.